We got all this data packed in densely, and then we have this big long string over here on the right. And it's really stretched out my data over on that side, meaning there's not many dots over here for the size of the area, okay? So in a box and whisker, when we have a lot of data packed in on the left and very few amounts of data spread out across the right edge, we're going to call that skewed right, which is the best measure of central tendency, okay? That goes back to my two options, mean or median. And skewed data always goes with the median. What's the best measure of spread? Well, the measure of spread that goes with skewed data and with the median is IQR. Our other option is MAD. MAD goes with symmetric data and mean. Determine if any outliers exist. If so, calculate. For that, we need to get our fences up again. Our lower fence is again Q1 minus 1.5 times IQR. Our upper fence is Q3 plus 1.5 times IQR. These are easy, quick calculations on this one. Our Q1 is 6. Our Q3 is 8. So what we're looking at here is 6 minus 1.5 times the IQR. Well, 8 minus 6 is 2. And we're looking at 8 plus 1.5 times the IQR of 2. Okay? When we do this, we throw it in the calculator, or you just know that 1.5 times 2 is just going to be 3, but let's just be safe. 6 minus 1.5 times 2 is going to give me a lower fence of 3. Eight plus that same thing is going to give me an upper fence of 11. So when we build these fences, 3 and 11, 3 is down here. That's my lower fence. 11 is right here. That's my upper fence. We want to know if anything got outside our fences, if anything got loose, any of our data got outside our fence, if any of our box and whisker plot got outside that fence, okay? So what I'm talking about here is this left side, nothing went outside. You can see nothing got past the fence. And on the right-hand side, we see that we do have data outside the fence. Now, being a box and whisker plot, we don't have all of the individual data points, so we can't tell how many outliers are out here, but we know for a fact that there is at least one. Because in a box and whisker plot, the only two data points we know for sure are the minimum and the maximum. So your answer for are there any outliers, okay? There is at least one outlier at 14, the maximum in other words, okay? On to the back page. Here we have a histogram for number 3. And it starts out with a real tricky question. It says, how many trees are 75 feet tall? And most people's immediate response is, oh, how tall is this bar right here? 75. Oh, it's 10 high. There we go. There's my answer. But remember, in a histogram, these bins, which is the word for these wide bars, okay, the width of the bar, they contain any number from 75 up to, but not including 80, which means that we don't know if maybe all 10 of these trees were 75 feet tall. Maybe they were all 78 feet tall. Maybe there were some 76s, some 77s thrown in there. We do not know how many were exactly 75 feet tall. So we cannot tell. All right. After that, on B, it says how many trees were at least 80. Just like with the box and whiskers, we like to want to ask for percents. Whenever a histogram starts asking about at least and more than, things like that, that's when it's in our wheelhouse. At least 80 feet tall. That means everything from 80 over. Well, we can see clearly that would be 5, 6, 7 trees. How many trees were measured? That's why I went ahead and counted up how tall all the bars were, because now we just add this up, okay? We've got 6, this makes 14, 24, 29, 31 total trees were measured. Add up all the bars. Can you describe the distribution of the graph? This is actually one of the more difficult distributions to describe. A lot of people overthink this one, okay? They want to say like, oh, well, it's a little bit lower here, a little bit higher here, things like that. Remember, guys, a skew in our data is usually pretty obvious, like on the last problem, okay? A skew in the data would be these couple middle bars would probably be over here on this side or over here. Whenever our data rises up in the middle and evens out and falls off on the outside edges pretty equally, not even perfectly equally, just pretty equally, we say that it is symmetric data. Best measure of central tendency. Those two options are mean and median. On the last one, we used median because it was skewed data, and so for this symmetric data, we want to use the mean. Best measure of spread. Okay, again, on the last one, it was IQR because we were using skewed data. But here we have symmetric data, which means we use the MAD. Also, just remember that mean goes with MAD. It's part of the word. What is the bin width? Okay, the bin width just means how wide is each bar. Now, I've had a lot of people tell me that each bar is, 4.9 repeating wide. You don't have to be that cute and that fancy with it. Each bar is 5 numbers wide, 70 to 75, 80 to 85, things like that, okay? Number 4 gives us a new set of data. It says, what is the best measure of center and spread for the data? To do that, this is where we're looking to see if our mean and our median are similar. Because if they're similar, really close together, that means it's symmetric data. So we hop over here in the stat category, we delete whatever was in the lists. We have our new data, 46, 13. I'm already just looking, thinking this is probably going to be skewed data. I'm thinking that because as I was typing those in, I had a lot of 30s and 40s, then I had 2 standout data points of 9 and 13. They're going to kind of drag the average down, and at which point we don't want to use the average. But let's double check just to be safe. Stat calculate one variable statistics of list 1. Be careful. Our mean is 36.2 and our median is 41.5. Okay? That means that our mean is significantly less than our median. Whenever this is less than or greater than, it means we have skewed data. In fact, the fact that it's less than means that it is in fact skewed left. Okay? But the key thing is the fact that it's skewed, because anytime we have skewed data, okay, we want to use the median and we want to use the IQR. Those all go hand in hand together. Median and IQR for number 4. Number 5, list the order in which the measure of central tendency is affected. This question won't directly be on the test, but it's a general principle that you need to know. What this is boiling down to is asking, does an outlier affect the mean more? Because that's one of our measures of central tendency. Or does it affect the median more? And I keep reminding y'all to think about your grades. If you have a lot of 100s and you then make a 0, that's going to really drag your average down. The mean, it's really going to drag it down. However, if you've got a bunch of hundreds and then you make 1 0, think about the way we would do a median. You've got a bunch of hundreds in the grade book. Okay? And then you make 1 single 0. You just forgot to do your homework one day. Well, watch what happens when we calculate the median. The first thing that goes is that 0. It's out. We're not even using it anymore. Which means our mean, our average, is much more heavily affected by outliers. So most affected is the mean, least affected is the median. Number 6 is another big picture principle. Okay? What is the best estimate for the mean if the median is 3? Okay? Well, what we have to establish is that this is skewed right.